In this lesson, we are going to continue to look at how scale factors affect surface area and volume in two more questions. This question is looking at the Great Pyramid of Giza in Egypt. It says the Great Pyramid of Giza in Egypt was built on a square base with the dimensions shown. So the square base has dimensions of 230.4 meters, length and width. It suggests that the height of the pyramid is 146.6 meters, and the slanted side, this length here, from the bottom to the top on the slanted side, is 186.4 meters. An artist who works with plate glass wants to build a replica of the pyramid for an installation at an art gallery using a scale factor of 1 to 60. So he'd like to make it, the measurements, 1/60th as big. How much glass will the artist need to build the sculpture? Now, how much glass, that is surface area. So essentially, what surface area of glass will he need to build the sculpture? So here's one of the concepts that you may remember. One of the concepts is that the original area times the scale factor squared equals the new surface area. So we know that the scale factor is 1/60th. And we'd like to know, I'm going to call the original the real pyramid. And this is going to be the glass pyramid. So here's the big idea. If we can find out the surface area of the real pyramid, then we can just multiply it by the scale factor squared, and that will give us the surface area of the glass pyramid. So let's go ahead and find out the surface area of the real pyramid that's in Egypt. This is one of many methods. So the surface area, there's 5 surfaces. We're going to assume that we're going to have a glass surface on the bottom as well. So here is a net of a pyramid. There's 5 surfaces, one square and 4 triangles. And here is the 1 square, and 2 times length times slanted side represents the 4 triangles. So here's the formula for surface area of a pyramid. Or of a square pyramid. So your surface area would be L squared, which is 230. So this here is your L, 230.4 squared, plus 2 times 230.4 times the slanted side. And this here, 186.4 is your slanted side. Okay, so if we evaluate that value, so 230.4 squared is 53084.16. That's plus, and this is 2 times 230.4 times 186.4. That's 85893. 85893.12. So if we add those, the surface area of the real pyramid in Egypt is equivalent to 138,977 meters squared. So if we take that value, the surface area of the real pyramid, 138,977.28, and we multiply that by the scale factor squared, we will get the surface area that we need for the glass pyramid. So let me square 1/60th. So if I do 1 divided by 60 and square that value, I will get 0. This is scientific notation, but this is 0.00027 continued. So 0.00027 continued. And if I multiply the surface area of the real pyramid by that value, we get 38.6. So he will need roughly 38.6 meters squared of glass to create his scale pyramid. And the final example is example 4. The smaller tank in the photograph, so this smaller tank here has a capacity of 1,400 meters cubed. Okay, and the larger tank has a capacity of 4,725 meters cubed. So those are volumes. During the refining process, both tanks are filled with oil from a pumping station at the same rate. How many times longer will it take to fill the larger tank than it will take to fill the smaller tank? So how many times longer will it take to fill 4,725 meters cubed than 1,400 meters cubed? Since these are both volumes and we're pumping volume into it, we just need to know how many times greater this volume is, the larger volume, 4,725, than the smaller volume. So really what this is just finding out 4,725 divided by 1,400, because that will give you the difference in the volumes, or the quotient of the volumes. So it would take 3.375 times longer, because that's how much greater the volume is. Okay, so that would be how much longer it takes. Part B says how many times greater is the radius of the larger tank than the radius of the smaller tank. Now in this particular question, I don't think the radius would be 3.375 times greater. What this is actually the scale factor cubed, because this is the difference in the volume. Or in other words, what we know right now is that the smaller volume times 3.375 equals the larger volume. However, that does not mean that the scale factor or the difference or the larger radius is 3.375 times larger. This is scale factor, whereas this here is the relative volumes. Now, a little bit of a tricky question, but since we know the relationship between the volumes, we also do have a formula to deal with that. We know that original volume times scale factor cubed equals new volume. Okay, so if you look at this, what we actually know is that how the volumes are related is the scale factor cubed, because here's your relationship. So we know that the scale factor cubed is equivalent to 3.375. So if you want to solve for the scale factor, you would have to take the cubed root of 3.375. And the cubed root of 3.375, so an interesting question. It's equivalent to 1.5. So your scale factor is 1.5. Now since these are not areas or surface areas or volumes, these are simply measurements, radius. They just would be related by the scale factor. So the larger radius is 1.5 times the smaller.